So hey guys, my name is Aman Maleva, bearing the USN 1VE 21IS 003, and today my assignment is in design and analysis of algorithm, and I'll be covering the topic, the quest for efficiency, navigating the time complexity with sequential search algorithm. Content. Introduction. What is sequential search? Advantages of sequential search and disadvantages to algorithm for sequential search, time complexity of sequential search, improving sequential search, real-time applications, and finally the conclusion. Introduction. Today we're going to talk about one of the most fundamental concepts of computer science and programming, that is sequential search. We're gonna talk about the advantages and disadvantages and how it can be improved. But before we know the nifty-gritty details, we need to go back and learn what is sequential search. For that, I have an example. Imagine you have a large data set that you need to search through. How do we go about doing that? This is where sequential search comes in. It's a simple yet powerful algorithm that allows you to search through a list of items one by one until we find what we are looking for. But as with any algorithm, there are trade-offs to consider. The time complexity of sequential search can impact performance, especially for larger data sets. So understanding these concepts is crucial for any programmer or computer scientist. What is sequential search? Sequential search, also known as linear search, is a simple algorithm used to find the specific elements in a list of array. It works by sequentially checking each element in the list until the desired element is found. To illustrate this, imagine you are looking for a specific book in a library. You would start at the beginning of the shelf and check each book one by one until you find the one you're looking for. This is essentially how sequential search works. Advantages of sequential search and disadvantages of sequential search. One of the main advantages of using sequential search is its simplicity and ease of implementation. Unlike more complex algorithms, such as binary search and hash tables, sequential search can be easily understood and implemented by programmers of all levels. Another advantage of sequential search is its ability to handle unsorted data. Since it searches through each and every element in the list, it does not require the data to be sorted beforehand. This can save time and resource compared to the other sorting methods. Disadvantages of sequential search. Sequential search can be quite insufficient for large data sets. This is because the algorithm has to iterate through each and every element in the dataset until it finds the desired value. As a result, the time complexity of sequential search is big O of n, where n is the size of the dataset. This means that as the dataset grows larger, the time required to find a particular value also increases. For example, imagine you have a list of 100 names and you need to find a particular name. If you use sequential search, you would need to check each name one by one until you find the one you're looking for. This could take a long time, especially if the name you're looking for is towards the end of the list. Algorithm for a sequential search. The algorithm for sequential search is a simple process of iterating through a list or array until the desired item is found. It starts at the beginning of the list and checks each element one by one until the target value is found, or the end of the list is reached. If the target value is found, the function returns the index of the value. Otherwise, it returns a not found message. Here is an example of pseudocode for the sequential search algorithm. Function sequential search in brackets list comma target I for I in range length list. If list of I is equal to target, return I, return not found orbs. This code is written in Python. This implementation uses a for loop to iterate through the list and check each element against the target value. If the target is found, the function returns the index of that value. If the entire list is searched and the target is not found, the function returns not found as a message. Time complexity of sequential search. The time complexity of sequential search is big O of n, which means that the time it takes to search for an item in a list increases linearly with the size of the list. This can have a significant impact on performance when searching through large datasets. Improving sequential search. One way to improve sequential search is by using binary search. Binary search works in dividing the dataset in half and checking if the target value is in the first or the second half. This process is repeated until the target value is found. Binary search has a time complexity of big O of log n, which is much faster than sequential search for large datasets. Another way to improve sequential search is by using hash tables. Hash tables work by storing key value pairs in an array where the key is used to calculate the index of the value. This allows for constant time lookups, making it very efficient for searching. However, hash tables require more memory than sequential search or binary search. The real-world applications of sequential search. Sequential, sequential search is a fundamental algorithm that is widely used in computer science and programming. One of its most common applications is searching for a specific item in a list of database. For example, imagine you have a list of customers' names and you need to find a particular name. Sequential search can be used to quickly locate the desired name by checking each element in the list one by one until the target's name is found. Another real-world application of sequential search is in web search engines. When you enter a query into a search engine, the engine uses sequential search to scan through its index of pages to find those that match your query. This process is repeated for every query entered in the search engine, making sequential search an essential component of modern information retrieval systems. Conclusion: understanding sequential search algorithm and time complexity is crucial in computer science and programming. As programmers, we need to be able to choose the right algorithm for the job and optimize it for the better performance. By mastering these concepts, we can become better problem solvers and create more efficient and effective programs. Thank you.